Now let's get started with a short overview on today's slides. In this talk, we will cover a few topics. The first one is decision criteria for choosing a solver when you start an optimization project or when you are already in an optimization project. The second topic will be common scenarios that we have seen from our customers when they discovered that they need to switch to a commercial solver like Gurobi. And in the very end of today's talk, I would like to show you some examples how it would look like if you are switching from a different solver to Gurobi. So let's start with the decision for a solver in an optimization project. Before you can actually decide which solver to choose, you of course need to know what solvers are around. For today's talk, I have divided them into three categories. The first one is commercial solvers. An example, of course, is Gurobi, but there are also other commercial solvers around like Cplex or Express. The second category are open source or free solvers. And here, some examples are LPsolve, GLPK, or Skip. In the third category, I want to put the modeling languages or frameworks. They can also be divided into commercial and open source. Examples for commercial modeling languages are AMPL and GAMS. But I also want to mention three modeling frameworks here that are open source. Two of them are written in Python. They are called Pyomo and Pulp. And the third one I want to mention here is called JUMP, and it is written in Julia, a fairly new programming language. Of course, this overview here isn't complete. These are just a few examples for solvers. There are more solvers around, but I didn't want to put all of them on this slide here. So how to choose which solver is the best for you? We figured out different criteria that our customers are looking at when they choose a solver. So for example, budget and licensing is a very important topic when you choose a solver, but also performance and scalability, professional support, active development are important if you are starting an optimization project. Most of our customers deploy their software to their customers, and so deployment and the ease of use of the solvers is also something that you have to take a look at when you choose a solver. And the last point mentioned on this slide here is complexity of switching later. What do I mean by this? So when you start an optimization project and you decide for a solver, and you figure out after a year or a month or maybe even 5 years that this solver is not the right one, the question of course is how complex and how much work does it take to switch to a different solver? For all of these criteria, I have prepared a slide to show you the advantages of the commercial and the free tools, and to point out which one is the one that wins this specific point. Here is a short overview. So for budget and licensing, the free tools, as they don't have licensing fees, have an advantage here. Another example for active development, the commercial tools, as they have a team of developers normally, definitely have an advantage here, but also some free tools offer very active development. What's definitely true is that the modeling frameworks are the best option if you have to consider switching later during your project. So let's come to all of these points in detail. Budget and licensing. For the free and open source tools, there are actually no license fees, and for most of them, there's even no licensing at all. Additionally, it is possible to take a look at the open source code to see what is exactly going on inside the solver or the framework, and you can also change it. This is not possible for the commercial tools, as the commercial tools are normally black box solvers or black box tools. Additionally, for using a leading solver like Gurobi, you will in the end have to buy a license, and therefore you need a budget. And if you deploy your software to one of your customers, you also have to include the licensing mechanism of the commercial tool. But at Gurobi, there's still a way to get started for free. For example, we have our free academic licenses. You can just go to the Gurobi website, register as an academic, and there you can get an academic license. Additionally, we offer a program called Take Gurobi With You. So once you earned your degree at a university and you start at an industry, you can take your Gurobi license with you for 1 year for free. Details about this are also on the Gurobi website, or contact our sales team at sales@gurobi.com for more information about this. And the last option to get started for free are evaluation licenses. Here also our sales team is happy to assist you. One of the Gurobi focus points is definitely performance. We are very proud of our solver and of our performance, and that we are currently the performance leader. And so, of course, this is an important topic. The commercial tools, all of them are optimized for solving real-world problems. We have lots of customers that submit models to us, and they actually solve real-world problems. And so in our test set, we also have tons of them. The commercial algorithms are tuned and they work in parallel. Additionally, we take care that our APIs and all of our interfaces are very lightweight, and so they are fast when it comes to handle large amounts of data. For the free tools, we have seen many issues with real-world problems. I'm coming to this on the next slide as well. Free tools are normally fast for easy and smaller problems, but if you give them a real problem or a big problem, they can have real issues with solving them. Additionally, we have seen huge setup times for models that are a little bit larger than normal. Here is a little benchmarks where we compare the MIPLib 2010 benchmark set, which is a set consisting of 87 models that were submitted from industry and universities. And that is a public benchmark set. It's around since 2010. And there are public benchmarks available on this test set. The runs that you can see here are made on one thread, to be fair, to be comparable with the free tools. And it has a time limit of 2 hours. This slide shows an overview of a few free solvers and a few commercial solvers in the first column. In the second column, you can see how many of the 87 problems these solvers could solve within the time limit. And in the third column, you can see the performance of the solvers. So what this shows is that GLPK and LPsolve haven't solved a lot of models. So GLPK wasn't able to solve a single model within 2 hours. LPsolve just solved 5 models within 2 hours. And so for these two solvers, we actually cannot compare the performance, as they just solved too few models to compare it, really. The next two solvers are CBC, which is the MIP solver of Coin, and Skip. And in this specific case, we use Soplex as an LP solver. And those already could solve 53 and 71 models, which might not sound too bad, but if you take a look at the performance, for example, of CBC, you can see a 32 there. And this 32 actually means that CBC was 32 times slower than the best solver. And the best solver on this benchmark currently is Gurobi, and this is rated with A1. Skip is much faster than CBC, but still it is more than 9 times slower than Gurobi. And the last 3 lines in this table here show the commercial solvers that we compared. The 3 commercial solvers are Express, Cplex, and Gurobi. And you can see that these 3 commercial solvers were able to solve almost all of the models within the 2 hours time limit. So Gurobi solved all of the 87 models. In the third column, you can see that the performance of these 3 solvers is much better than the performance of the open source tools. And you can also see that Gurobi is the fastest solver. This benchmark is not just something that Gurobi has done, it is actually available, and you can find it on that link there. This benchmark is done by Hans Mittelmann. He is at the Arizona State University, and he compares the different solvers that are around also on different number of threads and for different test sets. So this is just an example. If you're interested in the details, you can just go to his website and take a look at all of the benchmarks he's doing. 2 slides before, I also said something about huge setup times. And in this slide, I want to give you an example what that could mean. In this test, we build and solve a model, one single model, and we used 4 different APIs to build that model. This model has 2.5 million variables, 5,000 constraints, and about 500,000 non-zeros. And it is the same model that we built once using Gurobi's Python API. Then we used Jump, the Julia modeling language. And we also used the 2 Python modeling frameworks, Pyomo and Pulp. And the overall runtime of that small program that actually built the model and solved the model, for Gurobi's Python API, it just took 22 seconds. In Julia, it took 40 seconds. With Pyomo, it needed 146 seconds. And in Pulp, we needed 203 seconds. And just to show you the optimization run, so the actually solving of the problem, for all of these 4 runs, Gurobi just took 3 seconds, and we used Gurobi to solve it in all of these 4 programs. So you can see here that using one of these open source modeling frameworks can take actually a lot of time when it comes up to building large models. The next point on our list is professional support. Free tools often have very motivated developers that do a lot for their tools, but they can only offer limited support. The commercial tools normally have a dedicated team of experts. Here at Gurobi, we have a team where everyone has a PhD in optimization or discrete optimization, and we guarantee fast response time. Additionally, we offer 2 hours free consulting, where we try to help you with your model to figure out how it could be modeled a bit better or how we can somehow improve performance. We also offer parameter tuning, which means that you can send us your model and we take a look if there are any parameters inside Gurobi that we can change to make it solve faster. Also, all commercial tools have active developers, which means lots of things are going on, and from version to version, actually the performance improves all the time, and also additional features were added to the solvers. So our developers, they don't do anything else than looking at the code all day and try to improve Gurobi. And in this short table here, you can see a benchmark. This is a little bit different to the one that we have seen before. It is run on an internal test set that has about 3,500 models in it. It's about MIP models. And here you can see the number of unsolved models for the different Gurobi versions. So starting from Gurobi version 1.1, you can see that we were not able to solve about 530 models within a time limit of 10,000 seconds. And over time, I have to say this runs are all done on the same machine. Of course, you could say Gurobi version 1.1, the machines have been super slow compared to today, but we have run this benchmark on the same machine for all Gurobi versions. And in the latest Gurobi version, which is 7.5, there were only 46 models that we could not solve within the time limit. So this shows that our developers are doing a lot to make Gurobi faster, more reliable, more robust, and be able to solve real problems. The next point is deployment. So when you work for a company and in the end you're integrating Gurobi in your software and then deploy it to your customers, it is very important that this deployment happens in a smooth way. So for the free solvers, the support of different operating systems is very limited. Of course, if it's an open source tool, the source code is available and you can just compile it on a different system. But if any issue occurs, then you're more or less left alone and there's no additional support for a specific platform. For the modeling frameworks, even though there are commercial frameworks around, you still have to think of that this is an additional piece of software that also needs to be deployed. Depending on if it's free or commercial, you need another license, and you need that additional layer that is between your data and the actual MIP solver, and you need to also deploy this. Some of the modeling frameworks are also file-based, which means that they write out the model to a file and then will pass that file to a solver. And this can sometimes make things a little complicated. For the commercial solvers, there are a lot of operating systems that we support. And also we are flexible when it comes to new situations. So if there is a new operating system showing up or a new way to use a specific operating system and it is currently not supported, we normally try to do our best to support it in the next version. And if this is not possible, we try to find a way that allows you to use it directly. And this brings us to our next point, the ease of use. Of course, you want to build up your optimization problem and model it in a way that is easy to do for you. You want to use your favorite programming language. You don't want to learn a new syntax, for example, and you also want that others that work together with you can read it easily. And so it is very important that the APIs are easy to use. For the free solver, sometimes there are only C and C++ APIs around. Of course, if you are a C or a C++ developer, that's not an issue at all, but many people coming to us and saying that they don't want to use C or C++, they want to use Python or something easier. And so for the free solvers, the usage is sometimes a little bit complicated. If you already have a favorite programming language, then also the modeling frameworks are not that easy to use because you have to use their syntax. They have a very nice syntax and you can easily read it and you can also easily learn it, but it is a different syntax to, for example, Python or Java. The commercial solvers normally have APIs in all popular programming languages. So for Gurobi, we have APIs for C, C++, .NET, Java, MATLAB, R, and of course Python. And Python is a little bit of our favorite API. We're adding more and more nice extensions to Python to make it a little bit more look like a modeling language and make it very easy to use for people that are not used to use a programming language. I will give you an example later. And the last point on the list is complexity of switching. So once you started your optimization project and it seems in the beginning everything was running fine, you were, for example, just optimizing planning problems for a week or so. But after a while, as this is working so great, someone comes up with the idea, oh, let's not just plan for the week, let's plan for the whole month, or let's do the plan for the whole year. And this is the point where lots of free tools get to their limits. Because if the models are getting bigger, their results sometimes are not robust and they sometimes even cannot solve these models. And so you might have to consider switching to a different solver. If you are using a specific solver, then switching, of course, is not super easy because each solver has its own APIs and its own method and calls, and you have to somehow rewrite your code to use a different solver. So these solver APIs, they are not used to make switching easy. If you're using a modeling framework, then it is very easy to just change the solver because sometimes it is just one line where the actual solver is called. I will come to that on a slide later in the switching example section. So when is the time to switch? We've seen quite a few common scenarios from our customers. They come to us and say, our model is getting larger and it takes so long to solve with a free solver. This is just like the situation I described before. You might consider a much larger horizon for planning, or you want to take a look at a situation in more detail and your model is getting larger. And then it's definitely a good point in time to try a commercial solver like Gurobi. Our model is getting more complex and a competing commercial solver is running into performance issue. This is also a good point where you should contact our sales team and ask for an evaluation license, or contact our support team and send a model to them to see how Gurobi performs on your models. As you have seen, we are the performance leader, so there is a good chance that our performance is a bit better. The results we are getting are not robust and reliable. We have had lots of questions like this before. Mostly the people that have these issues are coming from the free solvers, and the free solvers sometimes will just crash or will not solve the models. As my benchmark example shows, they are not really able to solve a lot of the real world problems. And so there is a very high chance that Gurobi will be able to solve your models. So just contact us and ask us for a license. And the last point here is we need help on parameter tuning. Our support team is happy to assist you with this. So a first test how to find out if Gurobi's performance is good for you, it can be done very easily. You have just to export an MPS file and then you can check performance. How to export an MPS file from your specific solver, we show on our website. And here is the link. You can actually also click just on gurobi.com and there you will find a tab called resources and there is switching to Gurobi. There we show how to export an MPS file from the different solvers and modeling languages. Then you have an MPS file. You can then ask for a Gurobi evaluation license and do the test on your own. Or you can just send that file to the support team, support@gurobi.com, and we are happy to run that file for you. Running an MPS file is very easy. After you install Gurobi and you got your license, you just have to call the Gurobi command line tool from a command line, as the name says, in the way that I've written down here for you. So it's Gurobi_cl and then my model.mps. In this example, I also added a time limit and a mipgap, but of course you can change these values to what you are looking for. So let me summarize what we have seen and when switching to Gurobi is a good idea. If you are interested in robust results, and by robust here, I mean that the solver is not crashing, that it always returns a solution in a time limit that fits for you. Also, scalability is an issue for you. If your models are getting bigger and bigger and you don't know where the model will end up, then having a commercial solver is a good idea. And one point that I added here is the Gurobi compute server. So Gurobi offers a special technology that allows you to build your model on a client and then hand it over to a compute server, which might be a much more powerful machine that you have somewhere, and then run your model on that machine instead of running it on your client. And this special technology, more details about it you can find on our website, is a very good point when it comes to scalability. This technology is also included in our cloud offering. So if you don't know how large your optimization projects will get and how many models and problems you will have to solve, then something like a cloud solution is definitely a good idea, because then you can scale up the machines, the number of machines in the way you need it, and you don't have to buy new machines all the time. Solving speed, of course, is a very important issue because you don't want to wait for 2 weeks to get a result for your optimization problem. You might just want to wait for 2 hours, and then a commercial solver is the best choice for you. And the last point here is maintenance and support. As I said before, we have an active team of developers that are making our code better and better and increasing the performance a lot. And we also have a great support team that helps you if you see any issues or if you have any questions. So now we come to the switching examples part. Before I show different examples for the different solvers and the modeling frameworks, let me give you a short introduction into our Python API. So we really love our Python API, and this is why I am showing it here. We also have APIs for other programming languages, but it would take quite a lot of time to show you all of the APIs, so I'm concentrating on Python here. In Python, it is very easy to build up a model. The first thing that you have to do is call the model constructor. This is the first line here, and give the model a name. In this case, we call it mip. And the model object is called m. Then you can add variables. And here we have 3 variables. The first one is called x, and it's a binary variable. The second one is called y, it's a continuous variable, and the third one is called z, and it's an integer variable. Of course, an optimization problem also needs an objective. And adding an objective, you can just write it down in the way you would write it down on a piece of paper. In this case, our objective is x plus y plus 2 times that, and we want to maximize it. And setting this objective is done by the setObjective method of the model object. Finally, we want to add 2 constraints to this model, and this is also very easy to do. You call the addConstr method of the model object, and then just write down the constraints in the way they look like. In this case, we have x plus 2 times y plus 3 times z is smaller or equal to 4, and this constraint we call C0. Then we have another constraint which is called C1, and this constraint is as simple as x plus y is greater or equal to 1. Once you have built up your model, you will just have to call m.optimize, which is the optimize method of the model object. But of course, your models will not be that easy, and they will not just have 3 variables and 2 constraints. So in the end, you will have to deal with much more complex models. And for those, we have added a few nice features to our Python API that make it much easier for you. I'm showing these features here on this slide, and before I come to the features, I want to show you how it was done in the old way, and it's still possible to do it that way, but it's just for comparing how it will look like now. So here we have a variable x that has 2 indices, I and j, and we build that variable in the following way. We construct an empty dictionary, then we have 2 for loops over I and over j, over the 2 index sets, and then we add a variable for each x, I, j. And this variable here is a continuous variable, and it has actually objective coefficients, and they are stored in the dictionary costs. And so we do it that way. Then we also want to add a constraint, and the constraint is there for the index set I, and this constraint sums up all the x variables for j, and this sum should be equal to a coefficient that is called d. And so this is how it looked like in the old Gurobi interface. And now with the new features, we can write these 6 lines down in just 2 lines. And they will now look like this. We can create the variables x by calling the addVars method, and we can just pass over the 2 index sets I and j directly to that addVars method, and also pass over the coefficients for the objective here. And then it is also very easy to add the constraints. There is no for loop needed anymore. We call the addConstraints method, and our variables now have a method called sum, and we can just sum up all the variables for j and make them equal to our coefficients d. So here is a little more complicated example so that you can see that you can actually work with this. This is a network flow problem. And for the model setup, we have 2 lists, the commodities and the nodes. We have a tuple list args that consists of the tuples of nodes. And we have 3 dictionaries, inflow, cost, and capacity. For the model, as it's a network flow problem, we need the flow variables. And these flow variables are there for every commodity and every arg. And we can just add them by calling the addVars method of the model m for the index sets, commodities, and args. And we set the objective coefficients to cost, which is the dictionary that is actually also indexed by commodities and args. And then we give the variables a name and call them flow. The nice thing about this call here is that we don't actually have to take care about unique name for the variables. We just write flow here, and Gurobi will take care that each flow variable gets a unique name by the different indices. Now we come to the constraints. The first type of constraint that we want to add is the capacity constraints. The capacity constraints are saying that for each arc, there is a limited capacity. So overall of the commodities for each arc, the capacity is limited to some value. And we can easily do this by calling the sum method of the flow variables in that way and say that this sum should be small or equal to the capacity for that specific arc. And we do that for all of the arcs. And then we have added for every arc one constraint, and we call that constraint cap in this case. And Gurobi again will take care that this name is a unique name. The last type of constraints that this problem here has is the flow conservation constraint. And everyone that has modeled the flow conservation constraints and has dealt with all of the different index sets knows how complicated it sometimes is to write that constraint down. And you can see here, it can very easily be done by calling the add constraints method. What we do here is we sum up all the flow variables for a specific node, add the inflow to that node, and say this must be equal to everything that goes out of this node. And we do this for all commodities and for all of the nodes J. And again, we call this node and Gurobi will take care of it, that the name is unique. So now you have seen our Python API, but I said I'm going to tell you how to switch from different solvers to Gurobi. And here are some examples how to switch inside one of the modeling frameworks that I have mentioned before. For them, it is very easy. You normally just have to change this one line, the line where the solver is called. So for Pulp, this is actually when you call the solve command, you say which solver you want to use. And here I show the Gurobi command line tool that could be used to solve it. In Pyomo, you actually set the solver before calling the optimize or solve command by choosing it via the solver factory. And this is how it could be done. In Jump, you actually have to choose the solver when you create the model. In Ample, there is a solver option that is called Gurobi Ample. And in GAMS, there is an option MIP that you can set to Gurobi. You have to be a little bit careful. If you're setting specific parameters for the solvers, you will have to adjust them as well because different solvers have different parameters. Sometimes they are actually doing almost the same, they just have a different name. And so you will have to adjust these parameters as well. Normally, you don't have to adjust the model because the model is built in the same way for all the solvers. On this slide, I would like to show how it would look like if you are switching from Pulp to Gurobi. So if you really not just consider still being in Pulp and then using a different solver, but switching from using Pulp to model your optimization problem to using Gurobi's Python API. So the first line here is the model object creation. And we have already seen how this works in Gurobi. This is just a different example here. It was easier to put on this slide. It's an assignment problem. And for Pulp, the actual constructor is the LP problem method, and it has a name, and you can already set the objective sense here if you want to minimize or if you want to maximize. The next step is to add variables. And in this case, we have variables for workers and shifts. So what we want to do here is we want to assign workers to different shifts to take care that every shift has enough workers and the workers only work if they are really available. And for the Gurobi API, we have already stored these worker shift combinations in a dictionary called avail for availability. And for Pulp, this is not possible in that way. And so we add the variables with workers and shifts as indices. And these variables here are continuous and they have a lower bound of 0 and an upper bound of 1. For Gurobi, the call is a little bit shorter because continuous variables are the default and the lower bound of 0 is also the default when you call advars, so you don't have to put it in there. The next step is to identify the objective function. For Gurobi, you now have to tell the solver that it is a minimization problem. For Pulp, you have already done this in the very beginning. But if you look at the actual call to set objective in Gurobi and in the LP sum call for pulp, you can see that they look very, very similar. So the quick sum function of Gurobi and the LP sum function of pulp, they almost do the same. So here we multiply the variables x with some coefficients pay, and we do this for all workers in all shifts. And it is done in almost the same way for pulp and for Gurobi's Python API. And then we also have to add constraints, and in pulp, we have to do this by a for loop. And again, we will call the LP sum function to add these constraints here, and they will multiply the availability of the workers with the variables of the workers, and it will only use this product if the availability of a worker is actually not 0, because if the worker is not available, then we don't have to add it here because he or she will not be able to work in that shift. And in the end, this should be equal to the requirement of the shift, so how many workers should be there in the shift. And for Gurobi, this call looks a little bit easier because we have this nice add constraints function. We can just sum up the x variables, and as we only added those x variables, that from the availability sheet, we already know that some of the workers are not available. And so we can leave out that if clause here. And finally, we call the solver to solve the problem. And for pulp, this is just prop.solve, and then say which solver you want to use. And for Gurobi, it is m.optimize. So you can see the syntax is very similar, and it's not so bad and not so hard to switch from one to the other. And now we are actually at the end of today's talk. If you're interested in more details and you need some more help, the Gurobi website is actually a perfect source for this. We have a very nice documentation there. We provide lots of examples in all of our APIs with lots of different applications. And you can just go there and take a look.
Let's do a short recap. So in order to get started with Gurobi, there is no need to pay a lot of money right now because there are many ways to get a license and to try things out. So first of all, we offer free academic licenses and also site licenses. So if you are an academic person, feel free to request a license from the website. Some of you may not know it, but if you leave the university, so for example, after you're finished and you move to your first job, you can actually get a free Gurobi license for 1 year for commercial use for you, and it's called the Take Gurobi With You program. So just feel free to contact us if you have questions how this works. Gurobi also has a lot of consulting partners, so they can help you with questions on how Gurobi works, how it could work with your software. And of course, you can obtain a free evaluation license. And it's not only the license, and you're not alone with this, but you also get the full PhD level support that is a regular part of any commercial Gurobi license. And if you want to, you can also get a 2-hour free consulting, so we can talk about your architecture, about your software, and the things that worry you, or if you see challenges. So let's discuss. There's also one more thing that we can do. Sometimes it's a good idea to tune the algorithms a little bit to your problem. So if you want us as part of your evaluation, we can also help you in doing some parameter tuning. So we can take a look at your model and recommend something. In order to get an evaluation license, it's quite easy. Just send an email to sales@gurobi.com. Let us know what you need and what you are planning. If you then just want to try it out yourself, Sonja already showed us that it's quite easy. All you have to do is you export the model as an MPS file, and then you can, for example, just run this MPS file from the Gurobi command line client. But you don't have to do it yourself. You can also send the files to support@gurobi.com, and the support team is happy to help you.